I'm getting old. I cannot find the correct transitions in this little piece of studio. So, Tarun, welcome back. First of all, we've seen you before. So welcome and please introduce yourself. Tarun, who are
Thanks.
you? Where do you come from? And what do you do?
Absolutely. Thanks, Darko and Kyle, for having me on the show. Real big fan of the show here. And I'm super excited to talk about asynchronous inference. But before that, a little bit about myself. I'm Tarun Sairam. I'm a product manager with the SageMaker inference team. And so, yeah, I manage the asynchronous inference feature that recently launched. So super excited to talk about that, give you guys some more context and, dive right in.
Yeah,
Excellent.
whenever I hear asynchronous, I just think of efficiency because
Yeah.
Right.
synchronous generally is a little bit slower. So I'm looking forward to this one.
Awesome.
Yeah. So talk to us a bit about this asynchronous inference. What does this actually mean for our customers? What kind of problem does this solve?
Absolutely. So, Darko, if you don't mind, like before that, let me set some context regarding what is inference, what are the inference
Yes.
options do we have today, and then maybe it'll make a lot more sense regarding where asynchronous inference fits into those
Yes,
options, right?
please.
So just to start off with, as Julia covered beautifully, like SageMaker helps you with the end-to-end machine learning workflow, right, for developers and data scientists. And you can prepare your data, build, train, tune your models, and then deploy them for production. And we also manage with the MLOps piece of it, right? So essentially, inference is the section of the workflow where you've built your model, you've trained it, you've tuned it, and now you're ready to kind of host it and get integrated with your other applications where you're feeding it requests and it's giving you machine learning response predictions in return, and then you're using that to infuse ML into your applications, right? So essentially, when I talk about inference, that's the stage I'm referring to.
Okay.
And
Okay.
today, like with SageMaker, you have three different inference options. The first option is called real-time inference, and that's a synchronous workflow. So think of it like you need sub-millisecond latency, like you're like a bank and you're trying to do like credit card fraud transactions, right? You get a request and you need to immediately within a second kind of figure out whether it's a fraudulent transaction or not and take the
Right.
relevant workflow. So synchronous real-time endpoints are like an option for that real-time inference, right?
Okay.
And typically, since it's so fast, the model sizes are pretty small, the payloads are small, and we usually the processing times are under 60 seconds. So that's option number one that we have. And the other option is completely think of the other end, wherein like you have video footage being recorded and you want to kind of kick off these workflows where you're kicking them off once a day or once a month. You don't need something active all the time, but when you need to process, you have all the data up front, and then you're using those. So we have a product called Batch Transform, which does
Okay.
exactly that, right? And so asynchronous inference kind of falls between the two. It kind of, I like to say that it gets the best of both features. So similar to Batch Transform, you can have really large payload sizes, you can have long processing times, and similar to real-time inference, you can process the requests as they come in. So really excited to, so this opens up a lot of new use cases, and really excited to talk about that here.
So turn I was curious, like when would like a mobile developer kind of see like because I'm only interested in me. I'm sorry. I'm sorry, web developers, but I'm only interested in me.
Absolutely.
and what I was curious about is like when would like a mobile developer kind of see this in action? And you said if asynchronous is a cross between the two where you're able to take batch and you're able to like process a lot of data
Right.
and do it kind of, I guess, like kind of in parallel, not necessarily saying in
Right.
parallel, but yeah. Then would this be like useful if let's say I had like a social media app or something like
Right.
that, and I wanted to send up all the videos and figure out like what's
Right.
like trending or something like that, like, and then that's like the For You page or something?
Yeah, great question, Kyle. Yeah, one of the canonical examples that we use is for like, let's say you have you work for an insurance company, and right, you have like this, you're trying to create this mobile app where you're trying to submit a claim. So essentially you got into a fender bender, you're taking pictures of your car, and you're through the mobile app, you're submitting those pictures to the insurance company. And since it's like let's assume that the workflow is that you upload these pictures and then you get a notification back saying that, hey, you know what, the status of your claim is ready, you can use it on here is the result of your claim, right? So for that use case, so here that is a perfect fit for asynchronous, right? So since your pictures might be very high resolution, so the data sizes might be in many MBs, if many MBs to many hundred MBs. So like you upload those pictures up, and then like let's assume that you have a machine learning model in the background which is processing these things and then generating a result. And it could even go, we also, SageMaker has integration with human in the loop services.
Right.
So we can also integrate with those kind of workflows if they are applicable to you. And so then it generates a return. So that would be a very good use case for asynchronous inference.
And I wouldn't even have to wait until like the next day to get that information back. Like it comes back pretty quick.
Yeah, here we are talking about a matter of seconds to minutes, depending upon the size and complexity of your model.
In essence, there's three options. There's the real-time one, which has limitations of file size, right? What is it? How much data can we do in real time?
Yeah, so typically, like our limits are about 6 MB for the payload and about 60 seconds for the processing time.
Correct.
So
that's in real time, right?
Yeah, that's for real time.
That's real time. And when we go a step further into asynchronous inference, you can have much larger payloads here, but the wait time, the time for you to come back for the inference to come back actually is longer than 60 seconds, right? So again, it's a perfect use case if you have a larger chunk of data which you wish to run inference on, but you don't want to wait a day for it, right?
Right.
So yeah.
So Darko, one thing to correct there is that like the payload sizes we support are up to 1 gigabyte. So these are in S3, and we'll go over that architecture and in a little more detail now. But also, like, it's not necessarily that regarding the processing time that you mentioned, it's mostly driven by the kind of ML model you have.
All right.
Gotcha. So if your model takes can process pretty fast in a matter of seconds, then there's no reason to wait minutes.
Fair point.
Got it. Yeah, that makes sense. All right. Well, I heard that there's a demo, so I kind of want to like see this thing in action. So
let's bring it up.
Would you mind sharing your screen?
Yeah, absolutely. So before we dive into the demo, like I want to do a couple of call outs for where you might use it, right? So one thing we mentioned, long inference payload sizes, processing times. We have a processing time up to limit of 15 minutes. So multiple, if you have a really complex model and you can't run it elsewhere, that async is a great fit for you. And as I mentioned earlier, similar to real time, you want to sort of process these requests as they come in. And so async is a great fit for that. And we'll cover this in later, but when we go over the architecture. But async also has like a built-in queue. So if you have like very spiky workloads and you don't want to expose those to your instances, ML instances processing the inference request, async inference would be a good option. And finally, like my favorite feature here is called scale down to 0. So you can configure auto scaling where like historically with real-time endpoints and with everything else, right? So you have an endpoint, you set it up running, and even when you're not, when the inference is sitting idle, so you still have to, you get charged for the compute instances. But with asynchronous inference, there is an option to scale down the endpoints, instances behind the endpoints all the way to 0. So you're only paying for when your endpoints are actively processing requests. So that's my favorite feature.
That's a big reason to use this, because ultimately, I mean, especially if it's not super time critical,
right? Exactly.
It should be perfectly fine because you get to not spend money.
Exactly.
What use cases would I use like scale down to 0? Like when would I want to add that?
Yeah, as Darko mentioned, like let's say there is a little bit of a trade-off here. You're trading off between latency sensitivity and your cost savings and cost efficiency, right? So let's say you have a scenario wherein like you're trying to let's say you're writing a mobile application for, let's say, a food delivery service, and you have a component there which analyzes the last 30 minutes of traffic and basically gives you an estimate of like, hey, this is your expected wait time, right? So that doesn't need to happen in real time most of the time, because let's assume that you're doing it once every few minutes, and then publishing it in your mobile app. So that would be a great use case wherein you can scale down to 0. And when the requests come in, you can then start up the workflow, process it, and then scale back down.
Makes a lot of sense. Is there some sort of a cold start to this one?
Absolutely. That's a great call out, Darko. So that was the trade-off I was alluding to. So there will be a little bit of a cold start penalty when you're scaling down to 0 and bringing it back up. So as as a developer, it's up to you to kind of say, hey, I have all these options. Here are my trade-off and what works best for my application.
Exactly. Thank you. Before you continue, I just want to welcome all the new people joining the live stream. Welcome to This is AWS On Air, a show where we get to talk about all the fun things that are being released on top of AWS. Today, Kyle is here with me, and we have Tarun, we have Anne, we have a bunch of other people here talking about Amazon SageMaker. And Tarun is going to be showing us how asynchronous inference looks like. So, Tarun, take it away.
Yeah, so today we're going to do a demo on asynchronous inference endpoints. And so this notebook is published on GitHub. So we're going to be sharing links to this notebook in the chat. So you're going to be able to try out everything that I'm doing here. And so this notebook is divided into 3 sections, basically. So the first, before we dive into the demo, I just want to give a list of overview of what we're going to do. And then like the high level sections are, the first section is all your basics. You're setting up your the surrounding information, your IAM roles, policies, and all those things, and getting ready for asynchronous inference. And the part that we're going to spend most of the time in is actually like what are the special configuration bits that you need to set for asynchronous inference, and we'll go with those in detail. And finally, like we'll do a sample invocation of the endpoint that we set up just to see like how it responds. So I want to, before we dive into the demo, right? So I want to give an overview of like the architecture and like the customer experience that you'd have to go through to use asynchronous inference, right? So this picture here shows like the setup of asynchronous endpoint. Essentially, the way that you would create an asynchronous endpoint is very similar to how you would create a real-time endpoint. So for those new to SageMaker inference, so essentially this consists of 3 steps, right? The first step is you're creating a model. So this is the model that you trained and you tuned and it's ready to go. And so you're creating a SageMaker model artifact, which has links to both the model and the serving container that you have. So essentially, you have flexibility here. You can either bring your own container, or SageMaker provides a list of containers for popular frameworks. You can use those as well, right? So the next step is you're going to specify an endpoint configuration. So with the endpoint configuration, you're going to specify that it's an asynchronous endpoint. We're going to go through all the fields that you need to specify. And that basically tells SageMaker that, hey, go ahead and create an asynchronous endpoint. Okay. And as you see here, with an asynchronous endpoint, there's an inbuilt queue. So this is a SageMaker managed queue. You don't have to worry about anything. You just worry about feeding requests into the endpoint, and SageMaker takes care of queuing the requests and feeding them to your endpoint when necessary. Okay. And in the endpoint configuration, you're also specifying your instance support, right? How many instances do I want? What is my auto scaling policy? What instance type? What's instance size? And all that good stuff, right? And so once that is the setup portion of the setting up the endpoint. And optionally, you can also have a SNS notification set up, so for success and error. So in case like after every request gets processed, send me a success notification to this topic, or send me an error notification to this topic. So only one of them gets generated based on the outcome of your processed inference, right? And the thing, so now we've set up the endpoint. Now it's time to invoke it, right? So here there's a slight difference between the way you would regularly invoke a real-time endpoint. And so with a real-time endpoint, you'd pass the payload along with the request to the endpoint. But since here we're supporting payload sizes that are possibly very large, up to a gigabyte. So what you would do is you would first put the data in S3 and then pass a pointer to the async endpoint as a request. And that gets queued in, and immediately you get an output location with the location of where it's going to put the result back, along with an inference ID. And so once the instance, depending upon the configuration and type of your instances, it's going to pull in that particular request whenever it's ready to be served, download the data from S3, process your inference, and then put the result back on S3. And then if you've signed up for your SNS notifications, you're going to get notified back.
And Tarun.
Yeah.
So question here. There's a wonderful question in the chat. Somebody's asking, Franklin Mo is asking, does this mean that you're only paying for the endpoint when the instances are down? Is there some sort of a charge when the instances are not being used, like when it's in cooldown? Is there some
right? So if you're configuring auto scaling, if you've configured auto scaling correctly, and so we're going to go over that configuration. So you're going to be paying only for the duration when your endpoints are actively processing the requests, right?
Wonderful.
So when you're scaled down to 0, that's the idea, right? So if you're remember the trade-off that we talked about earlier between the cold start penalty and your cost. So if you're happy making that trade-off, then this can save you some money.
Wonderful. Thank you. So
and just another question real quick before you continue. So like when I would probably use this, and let's go back to that, the food delivery app, right? And I'm trying to figure out when, what the wait time is going to be based off of, traffic and things like that. So I could essentially have everything all scaled up, like, which means like a lot of people are using my app during happy hour or rush hour or whatever you want to call it. And then, when it's, midnight, when only a few people are up, it may only start up like as needed.
Right? Yeah, exactly. So that's a common scenario that we say, hey, if you're like busy during mornings and lunchtime, and after that your traffic cools off in the evening, and you can tolerate that cold start penalty, by all means, like you can use that feature and save on costs.
Okay.
Show us.
Awesome. So let's go through a quick demo. So I've set up most of this. So the first section, so the initial setup regarding setting up the infrastructure and the IAM roles. So I've taken care of more of those. And so that's going to be common. So since this notebook is going to be published, you're going to be able to look at it upfront, right? So let me quickly walk through those, but we're not going to spend too much time on those. So initially, first you're downloading your dependencies, you're importing the Bodo 3 client for SageMaker, setting up the models. And here we have a sample use case where like we have the demo files that are the trained model artifacts and the responses. So we have that in an S3 bucket. I'm copying that locally. And then, so basically here, now we're ready to create a model. So here, as I talked about, there are 3 steps. So the first step is like creating the model artifact. So here you would specify the artifact the trained model artifact that you got from your training process. And one thing to emphasize is you needn't have done training in SageMaker. You could have trained your model elsewhere, and you could still bring those models to SageMaker and use them for your inference workload. So then after specifying that model, you would then specify the serving container here, saying, hey, let's say you had used TensorFlow, and then basically here you would have a serving container which supports TensorFlow, and you would also provide us that link here. So once you do both, you can have a container image based in ECR and basically pull that down. And then what SageMaker does is SageMaker creates something called as a model artifact, where it has links to both the container and the model. And that's like an immutable object that SageMaker will use going forward. And once you create the model, that's step 1. Right. Step 2 is creating what we call as an endpoint config. So here is where you're telling SageMaker that I'm creating an asynchronous inference endpoint.
So,
yeah.
This is where you define the instance sizes and how much instances.
Exactly.
Gotcha.
So that's exactly what we're doing here. We're defining the instance type. We're defining the instance sizes. We're defining the initial instance count. And the configuration specific to asynchronous inference is what we have here, where we tell SageMaker, hey, this is the output path where I want you to place my inferences after you process them, right? Gotcha. And you can you have the optional success and error topic here, where you can subscribe to get SNS notifications. And finally, the last parameter that I want to talk about is the maximum concurrent invocations. So this is where you can say, hey, at a time, process n amount of requests from the queue, right? And so this is completely optional. And so once you do that, you create your endpoint, and then this is the optional auto-scaling policy that we talked about. And since we are at time, I'm going to jump through that. And finally, like after you're done with it, you can just invoke the endpoint using the invoke endpoint async API, and then it gives you its.
Okay, excellent. So now, I mean, first of all, I love that you're running all of this from an IDE. So I'm a big fan of this, that you all do this from a wonderful README file, basically. So you've created an asynchronous endpoint through the use of SageMaker Studio, Jupyter Notebooks, and now that endpoint is ready to basically receive data, right? So on the step 2.1, you're actually invoking that endpoint with some data, right?
Right.
Correct. Okay. And what happens when you invoke that? What do we get outside?
Yeah, so that is exactly what we covered up front, right? So
okay.
The invoking the endpoint is the process where you put in a request, you have a pointer to your S3 location. So when it gets to the head of the queue, it gets pulled in, it gets processed. At that point, we download the artifact associated with your request, process your inference. Then if you've signed up for SNS notifications, we notify you, and then put the result back in S3.
Okay, excellent. So now, basically, the thing you've triggered here is going to trigger an SNS notification, send it back to the user, and it's going to... Okay, excellent.
You can use that to integrate it with your apps.
Awesome. Simple as that. I mean, to be honest, like it is pretty much straightforward, especially when you look at it like that. There's going to be a comment in the chat where you can find, I guess people can find this Jupyter Notebook somewhere, right?
We have it in our GitHub examples. And then we also have a What's New post that we're going to share with that. Excellent. And this has a link to the notebook as well. So we're going to keep adding to examples here. So keep checking our GitHub repo. And we're going to keep adding to these so that as new use cases come and we want to share them with you, we're going to keep updating that folder.
Excellent. Tarun?
Another use case where asynchronous is pretty cool.
I am still not cool with asynchronous, but we can chat offline.
All right. Whatever it takes, Darko.
Yeah. not with SageMaker asynchronous, but in general, I don't understand promises and not promises. So, but yeah. Tarun, thank you very much. This has been a pleasure having you here. We're gonna have who are we gonna have? We're gonna have Kirith joining us right now to talk about something that I potentially have experience with, Kyle potentially has experience with, something to do with pipelines. But yeah, Tarun, once again, thank you very much. And
thanks for having me on the show.
Yeah,
it's been a pleasure.
Good talking to you.
Thank you very much.